Hello, everybody. Thank you for coming back after the break. I hope the kids are back in class and the tea's with you. Thanks for joining for our first session and coming back for our second, our spotlight on timber. These spotlight sessions are a really great chance for specialists in one area to hear from specialists in another. So on this occasion, we have three speakers. I'd like to introduce Steve Mitchell, our first speaker, who's a principal consultant with Thinkstep-ANZ, and he'll talk about carbon footprint of Australian timber products. So, Steve, can I hand over to you, please?
Okay, so thanks everybody. Nice to virtually meet you. So I'm talking about the carbon footprint of Australian timber products. So I've got a fair few slides to get through, as is my want, but hopefully I'll give you an overview of a number of issues, and obviously I'm available for follow-up questions after the presentation or at a later date. So just a little bit about me. I've got about 20 years experience with timber in various iterations. I started off in the waste and recycling industry. From there, I've worked my way up. I've worked on legal logging, life cycle assessment of timber products, and also education and specification of timber products when I was with the Timber Development Association. So I've co-authored about 7 timber sector EPDs on Australian timber products, plus some company-specific EPDs. I'm the current chair of EPD Australasia, also an FSC and PEFC chain custody order with SCS Global Services. So just a little bit about EPDs themselves, environmental product declarations. Obviously, a lot of people know about them, but a number of people don't. But just a bit of an overview of what an EPD is. It provides environmental performance data for products, not just building products, but a whole range of different products. They're independently verified and globally recognised via EPD Australasia and our partnership with International EPD System. So they're based on international life cycle assessment standards and product category rules, and they use process LCA methodology to do the life cycle assessment for the products. So an EPD itself demonstrates a building product supplier's commitment to sustainability and transparency. EPD Australasia, who I'm the chair of, they have good governance and EPD update requirements as well. So they're embedded within the system. So it's been operating for about 5 years now and very successfully, and it's growing fast in Australia. So what is an EPD? They quantify the environmental impacts for the end user to make better decisions, more sustainable decisions. And they can include impacts across the entire life cycle. They definitely have the upfront carbon emissions. That's a mandatory component, but they can include the impacts across the entire life cycle. Data is comparable because they're developed to the same PCR. In the case of EN 15804, that's our product category rules for construction products. That's an important standard that construction and building products should be adhering to in this space. But we're more than a carbon. Carbon is one impact, but there are other impacts that are mandatory to report in an EPD. Things like contribution to acid rain, to algal blooms, summer smog, energy use, water consumption are just a few, but there's also waste and resource, non-fossil fuel resource use and other impacts. So it's more than about carbon. Today's focus is about the carbon life cycle, that an EPD reports much more than that. And EPDs are growing rapidly. We're all familiar with the term exponential growth now in the age of COVID, but EN 15804 EPDs are starting to increase exponentially. There's over 10,000 EPDs worldwide for compliant with this standard for construction and building products. And here's a range that are registered with EPD Australasia, including timber products, but a whole range of construction and building products for various structural, facade, fit out, even whole buildings. Okay, so moving on to the timber side of things. Trees grow from the air. It's an amazing material. It's an amazing biological entity. 50% of the dry weight of wood is carbon. That's removed from CO2 in the air via photosynthesis. which is powered by the sun. So that key concept is something that we want to follow through when we do life cycle assessment of tree-based products like timber. An important proviso when sourcing timber, though, and a lot of the assumption throughout this presentation is about ensuring that you're getting your timber from a responsibly managed source, a forest or a plantation. And a responsibly managed forest is one that balances environment, social and economic benefits. Fortunately, worldwide, we have certification systems for forest management that are internationally recognised. So the vast majority of working forests around the world are certified to one or both of these international standards. And most, but not all, forests and plantations in Australia from which we get timber are independently verified either against the standards of FSC, Forest Stewardship Council, or responsible wood, which is endorsed by PEFC in Australia and New Zealand. And internationally, forests are certified against other PEFC endorsed forest management standards. So that's the certification of the forest. But it's important as end users, you understand that you're getting wood from that sort of sustainably managed, responsibly managed forest. So chain of custody is that link between responsibly managed forests and plantations and the end user. Now, all the major Australian producers of timber products are chain of custody certified to provide FSC or PEFC certified products. What's important from an end user perspective is you ask your joiner and timber supplier for a valid certified claim on your invoice. And here's an example here of what a valid claim is. Chain of custody certification number for a particular supplier and a valid claim on your invoice. Doesn't mean enough that your supplier is certified. There has to actually be a valid claim on your invoice. So that's how you can sort of understand where you're getting your wood from and that it's certified by a third party as being well-managed resource. So a bit about the timber life cycle. Okay, we start off with our tree. We've learnt that CO2 is absorbed by the tree and half the dry weight of wood is carbon. Is taken from that CO2. Then we have emissions during the processing. They have fossil emissions in this grey arrow from burning diesel, using coal-powered electricity, biogenic uptake from our tree, but we also have biogenic emissions when the CO2 is released. That could be from burning. And we also have other biogenic emissions like methane or nitrous oxide. So when it's burnt, for example, it's not only CO2 that goes up the stack, it could be a little bit of methane or nitrous oxides. So they're called non-biogenic other emissions. So in the primary production side of things, you've got uptake of the CO2, but you also have some emissions of all three sort of sources. Haulage, processing, kiln drying, planing and wrapping, treatment, you have some fossil emissions from each part of that cycle, part of the life cycle. And I'll quantify those down the track. And post-production, you obviously have fabrication plant, transport, construction, use, maintenance, demolition and deconstruction, and you have emissions associated with those parts of the life cycle and end of life. And with a biogenic material like timber, the end of life options are a bit confusing. Hopefully I'll try and reduce a bit of the complexity, but there's various emissions and uptakes in various parts of the cycle. But those are the four main options at the end of life. Now, timber environmental product declarations, as I mentioned, we've co-authored 7 of those. There's 6 of them published now. We've soon got a one for Australian white cypress pine that's going to be released soon. So we have them done for sawn softwood, hardwood, particle board, MDF, plywood and glulam. We've also produced, a sector EPD for New Zealand, sawn timber, softwood, finger jointed radiata, as well as glulam, glue-laminated timber. And as I was saying, we've done EPDs for a company, XLAM, cross-laminated timber, based in Wodonga in Victoria. And we've got more timber company EPDs for other sawn timber products, as well as laminated veneer lumber, which has been lacking up to this point. But they're on its way. So that difference between sector EPDs and timber EPDs, I'll explain a bit more later down the track. There's a small distinction that you've got to be aware of, but I'll be using, when I talk about timber carbon life cycle examples, 3 examples. So this softwood, Australian softwood timber EPD, which is an industry average EPD, glue laminated timber, which is another industry average EPD or sector EPD for Australian glue laminated softwood, and also the EPD for cross XLAM CLT panels. So I'll be using the numbers from those 3 EPDs. Okay, so lots of numbers here. This is the Australian sawn softwood EPD. You'll see from the forestry process, from the harvesting, from roads maintenance, etc., we've got about 27 kilos of fossil fuel emissions from that process. And this is based on 1 cubic metre of kiln-dried hardwood, by the way. This is the unit, and the emissions are kilograms of CO2 equivalents per cubic metre of that kiln-dried dressed hardwood. So haulage adds another 7 kilos, diesel emissions, processing another 34, kiln drying another 86 kilos of CO2 per cubic metre of timber, planing 28, wrapping 2. So you can sort of see from this, packaging, small contribution, haulage, small contribution. The main impact in the softwood side of things is from kiln drying. More about that a bit later and how that's being improved. So you've got a total fossil carbon emission of 201 in the case of Australian sawn dressed softwood. Now here we've got some small emissions from non-CO2 biogenic carbon. That's a bit of nitrous oxides and a bit of methane from when some forestry residues are burned in the forest. A similar sort of occurrence at the kiln drying stage. But the other number here we're going to look at is there's equivalent of 900 kilos of CO2 embedded within that 1 cubic metre of timber. So that's actually physically in the wood. That represented as carbon, but it's absorbed 900 kilograms of CO2 during the growth phase, and that is embedded in the material at that stage. So this is all totals for A1, A3, which is cradle to gate in life cycle assessment parlance. So all those numbers add up to about minus 182 kilos of biogenic carbon and the fossil carbon footprint of plus 201. So with the EPDs, we now report those separately. Okay, so you're very clear about what's happening. So if we were to look at H2F or termite treatment for softwood, it adds about 11 kilos of CO2. So it's a very small increase for the additional termite treatment for Australian sawn softwood. So something for Glulam, which has additional steps. Now, glue laminated timber uses your raw Australian sawn softwood. So it comes with those footprint there and 210 kilos of fossil fuel emissions up to that point. Then we add a resin, finger joining laminating, which is pretty emissions intensive, mainly because of electricity usage. And Australia's electricity supply is pretty dirty, so that's why it's so high. And a small amount from wrapping. Again, some other non-CO2 emissions associated with a couple of those processes. And so the total there for Glulam is 380 kilos of CO2 per cubic metre of softwood Glulam. Now you'll notice here this amount sequestered is a bit different to the previous one, which is a bit, you would think it'd be the same because we're using Australian sawn softwood, but this particular mix of supplies, we did 4 supplies in this case, we're using a higher density Australian sawn softwood. And the amount of carbon that's absorbed by a tree is a direct function of its density. So if you've got a higher density material, you've got more carbon embedded in the timber product itself. So that's a reason for there's a higher number there. But again, that carbon embedded in the timber used in the Glulam follows its way through the system. So that's what exits the gate. Now, Australian Glulam, manufactured by XLAM, that also comes with a carbon footprint from the processor of about 180, which is a bit lower than we had for Glulam. There is some transport component of plus 9 kilos of CO2 from transport to the CLT plant. And again, mainly from the electricity usage at the CLT plant, a bit of impact from the resin. You've got a footprint there of 247 per cubic metre of CLT, and a bit from the wrapping, a bit more wrapping there because they use a bit more metal for the straps as well as heavy duty nylon. So the wrapping was a bit more energy intensive. So you've got a fossil carbon footprint there of plus 447 kilos per cubic metre of CO2 of cross-laminated timber. Again, you might notice the number's a bit lower in this case, and this is because they're using a lower density radiata pine. And that's why the number of, the amount of kilograms of CO2 embedded in the CLT panel are a bit lower on a per cubic metre basis. That's the reason for that number being a bit different. Okay, so that's the carbon footprint of those particular 3 products. With the EPDs, what we've documented, say for example in the softwood EPD, they've had a 12% reduction in their carbon footprint over a 10-year period. We're just about to release an update of this softwood EPD based on a 2021 financial year. So we documented a previous reduction in 12% of the carbon footprint over 10 years, and there'll be a similar reduction documented in the coming update. Now, why are those, and this is one of the strengths of EPDs, why are we getting a reduction in carbon footprint? Well, they're getting better recovery rates from their timber. They're getting more timber out of a log. They're decreasing their use of energy. You recall that energy was a big part of the fossil carbon footprint. Well, they've invested in continuous kiln technology, which reduces the amount of energy that they need to make the kiln dry the wood. And they're also investing in solar panels and green electricity, which is making their energy source greener. So just a slight difference. I mentioned the industry sector EPDs, which the Australian sawn softwood one is, and the Glulam. They're both industry sector EPDs. And we've also got company EPDs. Just a slight note about the difference. What you will find in an industry sector EPD is a report on the variation of the different indicators. So this is a grab from the softwood Glulam EPD. You can sort of see there's this is 4 different producers, and you can imagine there's a bit of variation in the results. And so we've got to document that in a sector EPD. So here there's a variation plus or minus the minimum. It could be 16.4% less, the fossil fuel footprint. It could be up to 9.4% higher. Okay. There's a bigger variation in the Australian softwood EPD. We interviewed, I think in that case, about 8 softwood plants. So there's a bigger variation. So this is something when you're using an industry sector EPD, you have to be very aware that your particular product is going to sit somewhere in that range. Okay, and if it's a big range, you might want to go with a specific company EPD to be sure what you're getting. EPDs for sectors have a good use in that they get people, some sectors where there's a lot of small producers, it can reduces the cost of producing an EPD. But we've got to report this publicly. With a specific company EPD, the product has to be less than plus or minus 10%. So you won't see a variation table on a company specific EPD because the rules state that they have to get verified to the variation can't be greater than plus or minus 10%. So you won't see a variation table in a company EPD. Okay, so timber at end of life. Okay, here's a bit of a journey. Reuse. What do you think happens to the carbon? Reuse timber, salvage timber, some people call it recycled timber. There's some really good providers out there in Australia of salvaging timber. Well, the carbon basically gets transferred to the next life. Doesn't get emitted, just sits with the timber. So that minus 900, say, of carbon sequestered in softwood, well, this gets carried over to the next life. Okay, simple. There's a bit of emissions from processing, from cutting, from transport, but you could sort of see from that life cycle assessment work we did for the other products, that's only going to be pretty small. So it's a good outcome. Reuse. Recycling. What's happening now is a lot of offcuts from joineries. from frame and truss manufacturers are being recycled back into long-lived particle board. A lot of single-use pallets get recycled back into long-life particle. This is happening over at Oberon with Polytech Borg facility over at Oberon. So they're transferring that carbon in the wood to the next life into a longer lived say, particle board flooring. There is a few emissions from biogenic sources, CH4, for example, a bit of emissions from CO2 from fossil fuel from additional processing, but the CO2 embedded in the product carries over into the next product. Timber, end-of-life timber use in energy, it's increasingly happening, not so much in the timber industry, but in the concrete industry, the cement industry, the brick industry. They're using waste wood to reduce their carbon footprint of their products. Okay. The CO2, obviously embedded in the timber, obviously goes up the stack. There's CO2. There's also some other emissions that aren't CO2, methane and nitrous oxides. But that's what's increasingly happening. And they're reducing their coal usage, but using a biological source of energy. That's how it gets accounted for within their system. Unfortunately, most timber in Australia still ends up in a landfill. That's changing, as I was talking about previously, but the natural fact is a lot of timber still ends up in landfill. The good news is that from a carbon perspective, it's not a bad outcome. Here's my mate, Fabiano Ximenez, who works for the Department of Primary Industries. He started off his career with them digging up landfills, finding that 46-year-old timber in landfill just hasn't deteriorated at all. It just sits there because the bacteria that makes methane or degrades timber can't live in the landfill. They can't eat the wood. He's now graduated from digging up landfills to doing all this in a lab in an internationally accepted methodology, and they're finding the same thing. Very little of the wood degrades in a landfill. Okay, so that carbon that's embedded in the wood product actually just sits there. There is some emissions from waste processing, as you would expect, but very small amounts of the wood decay. So that's my bit of a potted history of the timber life cycle. Happy to talk more, but I just want to take home some key messages about EPDs. Well, EPDs are really good. They encourage suppliers to measure and track their environmental impacts, including the embodied carbon of production. An EPD based on process LCA, like these are, and a PCR EN 1584 means the data is comparable. It's consistent. The life cycle assessment identifies the impact hotspots, and manufacturers can invest with confidence and reduce their costs. So why ask for an EPD? Well, for these reasons, you're driving demand, but you can also use the EPD and the data in them. And as we'll see from my following presenters, if you want to manage your project's carbon footprint, ask for an EPD. Use the independently verified data to improve your design and build, and do your bit to reduce environmental impacts. So they're my contact details. I think we've got a question Q&A after, haven't we, Hudson? So
we do, Steve. There's been a very lively chat and set of questions in the chat function. I've recorded a few, and we'll come back to that after our other speakers. You beat me. I was about to ring a virtual bell, and you've wrapped up so succinctly. Thank you. Look, I'm fascinated by that. Obviously, it is technical, but you've set out very clearly how the EPD process works, how it applies to timber, the fact that they're much broader in focus than just carbon, but for MECLA, the carbon is the focus. It's good to know there is a broader reach there, though. I didn't realise that 50% of the dry weight of timber is in fact carbon, so that's a handy fact I've picked up from your presentation. So many acronyms. I think with the common language piece, we might get you to do the translator of all of the EPD, the PCR, the FSC and the PEFC. There's a lot there to learn. But look, really, thank you very much for taking the time to set that out so clearly. I imagine I won't be the only one who found that really useful. So, Steve, thank you very much